So Module 2, Lesson 1 is Order of Operations. This is a prerequisite skill, meaning that we should have it to move forward in Algebra 1. So we're going to practice it for this module as Lesson 1. So we should be able to evaluate algebraic expressions by using order of operations. And how you'll know you've mastered this lesson is you're able to apply the order of operations with integers, decimals, and fractions. First skill we should practice is reviewing integer rules. So first, with addition and subtraction, we have addition of integers. When you're adding the same sign, you are going to have that same sign as the answer. So if I have a positive and a positive together, I'm going to get a positive answer. If I have a negative plus a negative, I'm going to get a negative answer. The rules for subtracting integers is you can keep the same sign of the first number when you're subtracting, but then you're going to change the operation from subtraction to addition and change the sign of the second number. So if it's a positive, you change it to a negative. If it's a negative, you change it to a positive. So here, for example, you have 5 minus negative 4. So instead of subtraction, we're going to change it to addition. You keep that 5 the same, change the subtraction to addition, and you change that negative 4 to a positive 4. This turns it into a simple 5 plus 4, which we know is 9. So here, instead of solving this, we're just going to think of what is the sum of 12 plus negative 3. Is it going to be positive or negative? So we have 12 positives plus 3 negatives. Here, I think there are more positives than negatives. So our answer is going to be a positive number, right? And we know that because we have 12 plus negative 3. That means we have 12 positives and 3 negatives. You could even draw it out like 12 plus signs, 3 negative signs, cancel them out. You're going to have 9 positives left over. Here, will the difference be positive or negative for negative 3 minus negative 12? So here, we're going to reverse this as from subtraction to addition. I keep the first part the same, so it's still negative 3. I change it to positive or addition, and then this has to change to positive 12. This will just be negative 3 plus 12. And we know that already it is just 9. That's the one we solved last. The rule for multiplication with integers, if they're the same sign, they're going to be positive. It doesn't matter if it is positive and positive multiplied or negative and negative multiplied. They're all going to give you a positive answer. For example, 5 times 4 will give you 20. Negative 5 times negative 4 will also give you 20. Those negatives cancel each other out. And with different signs, so positive times a negative or negative times a positive, you're going to get a negative always. So 5 times negative 4, nothing cancels out that negative, so the answer is negative 20. Negative 5 times positive 4, nothing cancels out this negative, so the answer is negative 20. These are the same rules for division as well. So division, same sign being divided, you get a positive answer. Different signs being divided, you'll get a negative answer. So these are the same rules for multiplication and division. Here, will the product be positive or negative when we multiply two negative numbers? Negative 3 times negative 12. We know that negative times a negative, or the same sign multiplied, will give us a positive. So this will be a positive 36, right? 12 times 3 is 36. Now it's asking for a quotient. We are dividing 12 by negative 3. There's only one negative sign here, and there's nothing to cancel it. So our answer now is going to be a negative number, right? They're opposite signs, we get a negative answer, -4. So the new content for today would be order of operations. When we evaluate problems with multiple operations, we have to complete the operations it involves in order, or else we're going to get very different answers. So the order of operations that we follow are grouping symbols first. That's going to be all the parentheses, brackets, absolute value bars, and anything like that. Then exponents would come next, or any roots. For example, 4 to the second power, that's an exponent. That's what you would move on to after you already sort out your grouping symbols. Multiplication and division are the same step. They come next. You're going to read the problem left to right. If you see division first, you do that first. If you see multiplication first, you do that first, but they are in the same step. Same thing for addition and subtraction. It is the same step. If you see subtraction first from left to right, you solve the subtraction. If you see addition first, you solve that first. You don't need to use all the steps. If you don't see any grouping symbols, then you don't solve any grouping symbols. You just move on to what you see first, going through this order. So, first example in simplifying expressions with integers, we're going to use order of operations to solve the following problem. So scanning this from left to right, I'm going to solve my parentheses first here. So in this parenthesis, right, these parentheses, I see 4 minus 2 times 3. Within the parentheses, I'm still going to follow the same order of operations. So I know from order of operations that multiplication comes before subtraction. -2 times 3 would give us -6, and this 4 just gets carried down here. Then I have the 4 minus 6. This will give me a -2. So I solved the parentheses here. And I know that everything in the parentheses was supposed to be squared. So I carry that down to my next part of the problem. And I'm going to copy the rest of the problem here. Next, from left to right, I'm going to solve any exponents that I see. -2 to the second power, that's just -2 times -2. Negative times a negative, we learned equals a positive. 2 times 2 equals 4. Then over here, the next part is 3 times 2 to the third. The exponent is going to just the 2. So 2 to the third power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this part is just 8. And the 8 is being multiplied by 3. Now that I've solved all the exponents, I go to multiplication or division. Left to right, I find this multiplication problem. 3 times 8 is 24. So once that's solved, it's just addition left. 24 plus 4 will give us 28. So we just performed all these steps of evaluating in order, following order operations. Now we're going to try with a fraction. So this is the same concept. We're going to follow order of operations, but we have to use a specific technique here because it's all in a fraction. And you have fractions like this, where you have operations in the numerator and operations in the denominator. You're going to treat it as a group. You're going to solve the top as something, the numerator, solve it all using order of operations, solve the denominator, and then divide the answer. So first, I'm going to start with solving what's in the numerator. -2.5 times 5 minus 15. I'm going to solve what is in my parentheses first. 5 minus 15 will give me a negative 10. And I have negative 2.5 times negative 10. A negative times a negative will give me here a positive number. And 10 times 2.5 is 25. Whenever you have anything multiplied by 10, you just move the decimal over to the right one. So this is positive 25. Numerator is positive 25. Then I have the denominator to solve. So negative 9.3 plus 4.3. I have negatives and positives here being added. I have more negatives than positives. How many more negatives do I have? 9.3 is 5 more than 4.3. So this would just be negative 5. So that is the solution to my denominator. So here I have 25 over negative 5. Our division rules state that a positive divided by a negative will give us a negative answer. 25 divided by 5 is 5. So my answer for this one would just be negative 5. So here I have 4 1/3 minus 2 5/6 times negative 1 over 2. So for this, I'm going to turn this all into like improper fractions so that I can then deal with it that way. How you do that is you multiply the whole number on the outside by how many make a complete set here, and then add the one on top, put it over that same base. So here 4 times 3 is 12, plus 1 is 13, so I have 13/3. Here I'm going to subtract 2 times 6 is 12, plus 5 is 17. I have 17/6. I'll multiply that by negative 1 over 2. It's already an improper fraction, or it's just a regular fraction, but there is no, it's not a mixed number, so I don't have to change it at all. So I'm going to start with the multiplication because that's what order of operations tells me. Negative 17 times negative 1 is positive 17. 6 times 2 is 12. I have 17 over 12 here, and that is positive because negative times negative equals a positive. So I'm going to add this together with my 13 over 3. The way that I add fractions is I need them to have the same base first. 3 and 12 have the same multiple of 12 in common, right? 12 times 1 is 12. 3 times 4 is 12. So I have to multiply my 3 by a 4 to get the same base here of 12. And that means I also have to multiply my 13 by 4. Right? If you multiply the denominator or something, you also have to multiply the numerator by that same number. 4 times 13 is 52. 4 times 3 is 12. I'm going to add that with my 17 over 12. So there I get 52 plus 17. 69 over 12. Those can both be divided by the same number of 3. So 69 divided by 3, I get 23 over 4. These do not have any more numbers in common. So I'm going to leave it as 23 over 4, or I can write it as 5.75 as a decimal.